All right, we're getting close to being done with our unit on exponents. So we need to have a little bit of reviewing and then take a quiz and call it good. So hopefully you're starting to understand this quite well. So I've got just a few sample questions here related to our review. So let's take care of these questions and then let you try the review today and see where we're at. So this first one says simplify. And it looks like we're going to be using the product rule where we multiply exponents that have the same base. And in this case, the same base that they have is u. So we have to keep in mind that this u over here that has no exponent written on it still has a 1 on there. And so when the rule is that when you multiply exponents with the same base, you just add the exponents. So this is going to give us u to the 1 plus 4 plus 4. So when we add those exponents together, we end up with u to the 9th power. Pretty straightforward, pretty easy rule to follow. And let's try another one. On this one, we've got y to the 5th times y to the 5th times y to the 2nd. So we have a few extra y's in there. Let's go ahead and make sure we put a 1 on that y that doesn't have an exponent because it's just always understood that it's there. And now let's go ahead and add the exponents. We're going to have y to the 5 plus 1 plus 5 plus 2 power. So when I add all of those exponents up, 5 plus 1 is 6, 6 plus 5 is 11, and 11 plus that last 2 is 13. So our answer would be y to the 13th power. Okay, moving along. What if we have something similar, but in this case we actually have numbers that we need to take care of, and we also have two different kinds of variables. We have y's, and we also have b's in here. Well, we're going to start out by multiplying the numbers. So we're going to have 2 times 3 times 3. So 2 times 3 would be 6, and 6 times 3 would equal 18. So as far as our numbers are concerned, we will get a 13. Now let's look at our y values. So as far as our y values are concerned, let's take a look at what we have there. So we have y to the 7th and y to the 5th. So if we add those values together, we have 7 plus 5, which is 12. So we end up with y to the 12th power. And then for our b's, and we'll change the color on these. So for a b, we've got a b to the 1st power and a b to the 6th power. And 1 plus 6 is 7. So for our b's, we're going to have 7th power. And that's what it looks like if you have more than just one variable in it. Okay, let's move on. Here's one where we have an exponent inside of these parentheses raised to another power. So we have to remember that everything inside the parentheses has some kind of a power. So like a -7 would have a power of 1. That b would also have a power of 1. And a already tells us that it has a power of 4. So then we're going to multiply that 2 by each of these exponents that are in here and come up with our answer. So we'll have negative 7 to the 1 times 2 power, which is 2. Then a to the 4 times 2 power. I said a to the 4 times 2 power. We got to just change the size on that. We've got a and then 4 times 2 is 8. And then b, we have 2 times 1 on the b power, so that's going to end up being b to the second. And then this negative 7 is still in parentheses over here because we haven't actually multiplied or done the squaring on it, but negative 7 to the second power is going to end up being 49, because negative 7 times negative 7 is positive 49. And then we have a to the 8th and b to the second. So that's what that one would look like if we use the exponent to an exponent rule. Okay, here's another one where we're just multiplying. So it's like the one we did a moment ago, kind of like this one. So this time we got 2w to the 9th times 4u times 4w to the, or u to the 8th times w to the 9th. So in this case we have 2 times 4 times 4. So 2 times 4 is 8, and 8 times 4 is 32. And next we have w to the 9th and w to the 9th. So when you combine those together, you get w to the 9 plus 9, which is 18. And lastly, we have u to the 1st times u to the 8th, which gives us u to the 9th power. So that would be the answer on that particular problem. 32 w to the 18th, u to the 9th. And keep in mind that all of these answers based on that, you have this little button that you can push that allows you to type in exponents easily anywhere that you need to have them in your answer. Okay, now we have one where we're actually dividing a monomial by a monomial. So we did a couple of these toward the end of our assignment. So let's take a look. Let's start with our numbers. 26 over 13. That just simplifies to be 2 over 1, or just 2. Now let's look at the x's. We have x to the 6th over x to the 2nd. So on the top we have more x's by 4. And then for our y values, we have y to the 2nd over y to the 8th. So on the y values we have more on the bottom by 6. So our answer would look something like this, but this 1 we can just drop. We don't even need to show it. And then we've got an answer, 2x to the 4th over y to the 6th. And don't forget all these little tools that are available to help you type in your answer. All right, I think we've got one more here. Simplify. Actually, we have two more. This one and one more. Write your answer using only positive exponents. And this is going to help us kind of combine dividing exponents, but also how do we treat negative exponents. So let's start with our number, 7 over 35. If we put that on our calculator and simplify it, we end up with 1 over 5, because we can divide them both by 7, and that's what we get. All right, so for our x's, we've got x to the negative 2 on top and x to the 3rd on the bottom. So if I move this x to the bottom, it's going to give me x to the 3rd times x to the 2nd on the bottom. And if I move this y to the negative 5 to the top of fraction bar, I'm going to end up with y to the 2nd times y to the 5th. So what does that look like down here? So we end up with y to the 2 plus 5, which is 7 power on top, and we end up with x to the 3 plus 2 power, or 5 power on the bottom, and that's going to be our simplified version of that algebraic fraction. So there you go. See, we got one more. This one's going to take into account the rule that anything with a zero exponent just equals 1. So let's see what we mean. Well, we've got a zero exponent here. We have a zero exponent here. We also have a couple of negative exponents that we got to take into account. And then lastly, firstly, we got a fraction here. So let's start with the fraction. If we do 8 over 48 and simplify it, that is going to come out to be 1 over 6. All right, now these x to the 0 power equals 1. And that y to the 0 power on the bottom just equals 1. So now all we have to do is figure out this y to the negative 2 and x to the negative 5. And we know that if we want to have an exponent that we want to turn into a positive exponent, because it's negative, we just have to move it either down across the fraction bar in order to get it to become positive, like in the case of y, or in the case of the x to the negative 5, we have to move it up across the fraction bar and make it positive. So we end up with our final answer as x to the third power on top and 6y to the second power on the bottom. So that's how you use the rules. That's just a few examples of what we've been doing in this unit. So good luck with the review today.